All right, new week, new unit. So I think you're gonna like this unit, especially compared to, like, say, trig. I know that that's a difficult unit for you. So we're just gonna hit the ground running. We're gonna talk about arithmetic sequences and partial sums today. Yes, I know that is the same spelling as arithmetic, just like the word read, like I read a book. I could also say I read a book. Arithmetic, arithmetic. Okay, so an arithmetic sequence is when I have a pattern and I'm adding or subtracting the same number over and over and over again. Okay, so like the pattern 0, 3, 6, 9, 12, that is an arithmetic sequence because you keep adding 3 to the number. So whatever number that I am adding or subtracting is called the common difference. So the hardest part of this unit is just making sure you know the vocabulary. So if at any time you don't know what the question's asking, of course that makes things harder. But what we're doing itself is not very hard. So that's good. All right. So in all of these examples, we want to know what is the common difference. I will probably just kind of keep on running. But what I can do is plug in 1, 2, and then 3. So if I plug in 1, 4 times 1 plus 3 is 7. 4 times 2 plus 3 is 11. 4 times 3 plus 3 is 15. That means that D must equal 4, because the common difference there is that it is adding 4 each time. So when I say that I'm plugging in numbers here, those are the terms. Like, what is the first term in the pattern? So like, what is the first number in the pattern? Okay. You could do the same method here, or you could know that it's what it's being multiplied by. So in this case, -5, and in this case, 1/4. So if you need to pause the video to see that, that's fine. Okay, so this question says, let the nth term of an arithmetic sequence have the form of A equals dn plus c. So that's what we just looked at, all the examples. What relationship does c have with d and a sub 1? So c is equal to the first term minus the difference. So here's how I think of that. Go back to that example we did. If I were to put one number in front, I call it a sub 0, like not the first term, but if there were one to come before it, what would it be? What would the number be if I am adding 4 every time? That means that this number would be 3, correct? Well, if I go back up and look at this example, I have 4n plus 3. So if you're ever given a pattern and say, hey, will you turn it into dn plus c, that makes it kind of an easier, quicker way to do it than some of the other stuff we're going to keep on talking about, okay? All right, so if we want to find the formula, we could use the a sub n one. However, for time's sake, I'm going to keep on rolling here. So the recursive formula is a sub, let's see, is this one, which we won't use very much. But however, this one I use all the time when I talk about arithmetic sequences. Okay, so how would I use that? There's a lot of examples. I'm trying to keep this short and sweet, so let's just look at Find the formula for the nth term of the arithmetic sequence whose common difference is 3 and first term is 2. So nth term means just find the formula. Just tell me the formula where I would plug in 1, 2, 3, or so forth and so on. So a sub n equals the first term. So that means first term plus n minus 1 times d. D is the common difference. Okay. If I was not concerned with simplifying, I would leave it there, but we're pre-calc, so we're going to simplify. So I distributed that 3 and then simplified to 3n minus 1. Okay. I could also think about if my common difference is 3, what is the one number before 2? It would be -1, and I would skip all the math. Okay. We will go over some of these examples in class, so make sure that you are present for that. And we're going to switch gears to sum. Sum. So the sum is of an arithmetic sequence is also known as an arithmetic series. Series means sum. And so sometimes if it's something small like this, what are the sum of the first 10 numbers here? I just add these up, right? So calculator makes that doable, nothing too bad. However, there is a formula that I can use, and the formula is this, where this is the number of terms. This is the first term, and this is the last term. So, number of terms here, there's 10 numbers. The first one is 1, and the last one is 19 to give me 100, because that's 5 times 20, which is 100. So that's pretty cool. I have a cool story that I'll probably tell in class to nerd out on you about where that formula comes from. It's not a true story, but it still makes life fun. Okay. But what if I wanted to find the 150th partial sum? Then we're like, oh, dang. That is a lot of numbers I'd have to write out and add. But luckily, we have these formulas to help me. So what I need to know is what in the world is the 150th term? It is not 150, but like, what is it? If I, had all those blanks there for 150 terms, what is the 150th? So what I can do is use the formula from sequences. I'll write it out first since it's not up there. So the first term is 5. I'm finding the 150th term, so that's what n is. And then the common difference here is 11. Okay. If we need to use our calculator, we can. I've already forgot the first part, sorry. So 1644. All right, so that's not the sum, that's just that last term. So now I use the second formula that we talked about for sums. Okay, so 150 divided by 2, the first number was 5 and the last number was 1,644. To save time on this video, I'm going to do that math for you. That's 123,675. All right, last two. Sorry, this video is just a tad bit longer. It's a lot of easier stuff, but I feel like showing you the different examples are needed so that you know how to use all of them. All right, so summation notation is a sigma. So if you got any friends in sororities or fraternities, you may have seen this symbol. It is sigma, but it actually means the sum of in math, hence summation notation. So going back to mathematicians are lazy. They don't want to actually write all of this out. Instead, they would like to put it in summation notation, where we start with the first term, and we're going to go up to 10 terms. Okay? And then we could do the arithmetic series formula. So let's just take the shortcut. What is the number that comes before then? It would be -1, correct? Because we're adding 4, adding 4, adding 4. So that means that this would be 4n minus 1. So why would I ever want to do that? Well, your graphing calculator for sure does it for you, and I'm about to tell you whether this one. All right, I'm not seeing it on here. I'm not saying it doesn't exist, but if we open up our graphing calculator, and I'm not sure how new this one is. Good, it's there. So if you hit alpha window, so remember, if you're on a Chromebook, you have the app at the very bottom there in the middle, and we're going to go to that second option. And we're just going to put that in. Now, I'm lazy and I like to put X just because that saves me from having to hit alpha and the letter. 1 to 10 for X minus, 1. Okay, and when I hit enter, it does the sum for me. So that is 210. So this is super helpful for like that 150th term one. I could have just found the arithmetic sequence and then I've done 1 to 150 instead of 1 to 10. Okay, so, all right, if you are a note taker, remember to put alpha window as your steps there. All right, so there are real world examples for it. I'm going to actually challenge you to do this one on your own, or definitely come to class and we'll talk about some real world examples live.